Jeff, you've invented a Gestalt AI. So tell us what that is.
So Gestalt AI comes out of the Gestalt research from the 40s and 50s. So it's been around over 60 years. The theory, it's an informational theory on how information is organized and manipulated. The Gestalt AI we built is used to solve problems through curious learning. It does that by following some top-level processes. It observes the data stream that it's looking at. It then figures out what the measurements are in that stream in symbolic and metric terms. It moves over to thinking about that, to considering how those things are propositioned to each other, or how they're represented with each other. And then it learns from that to create a response set that answers the objective questions you ask it. The system is completely self-contained. It does this in a super additive manner, meaning the work product you get out of it is more than each of those steps. When you run the entire process together, it constructs answers that are beyond the basic information in the set. It's not reductive logic, it's abductive logic. It gets bigger. It ingests unfiltered raw data streams, and in an unsupervised manner, it separates out signal-rich information from noise. So it just drops the noise out of the system. It learns in a continuous manner as it sees new data, and it contextualizes that data that it learns, that information it learns, in dimensions of time and dimensions of what fits with what. And then that gets used to discover answers in a technique that's in modern terms called few-shotting. We can actually do this from an initial zero shot, meaning no information present, and discover an objective term and then perfect our understanding of that objective term and be able to apply it to answer questions. And the AI does that through curious experimentation of the information it's presented.
Nick, you described the Gestalt AI as being able to extrapolate. Walk us through what that means.
So extrapolation is using data you know to estimate data beyond the range that you've observed. The difference between that and interpolation is, let's say you knew what the temperature was outside at noon and the temperature was outside at 2 o'clock, and you're trying to figure out what the temperature was at 1 o'clock. Extrapolation is, I know what the temperature is right now, and I need to figure out what the temperature is going to be tomorrow at noon. So how does our system do that? Well, it builds a local momentary model to answer the specific question that's being asked. And it builds that model in such a way that it is bounded by the context in which the question was asked and by whom the question was asked. These don't generalize, and they're not supposed to generalize. They're built specifically to that aforementioned point of view. So how does that avoid all the pitfalls of extrapolation? Well, where that would come in would be if you built a model and then tried to generalize it further and further away from what you already knew. The error becomes cumulative in that case. You become more and more likely to fail. We don't do that because we don't reuse models. We don't try to generalize them across a broad spectrum of data. We build a new one to answer the specific question that's asked by a specific user in that moment. And then when another question comes in, we build a new model. So there's no opportunity for those errors to combine and make the answers worse over time.
So, Nick, Jeff mentioned that combining techniques to exceed their boundaries. How does that relate to the idea of observing, measure, think, learn, and answer framework?
So in addition to being a Gestalt AI, this is also a modular AI. So what does that mean? Well, the observe, measure, think, learn, and answer pieces are all separate in design. They're modular pieces that have been combined together, but they're cooperative in operation, despite their being separated in design. Each piece does have its own algorithms, but we combine the results of those algorithms in such a way that the end answer you get when it gets to the answer step is actually of greater quality than it would have been in an individual step. So in this way, we can cross-reference, say, a geometric analysis. How close are all these points? Linear algebraic analysis. What's the solution to this system of equations? A signal processing analysis. What data points in here have real signal? Where are the peaks? Is this noise? Etc. And we can cross-reference and combine all of that to find information that's true from all points of view, which aligns back to what Jeff was talking about with the Gestalt information principle. because these pieces of information that are analyzed from all these different perspectives can fit together to reveal something that wouldn't be visible if you just looked at it from one point of view. Or even if it were visible, there might be so much noise around it in that one point of view that you couldn't be sure about it. As a result of this methodology, the system is capable of answering more complicated questions with smaller amounts of input data.
Jeff, so how general is Gestalt AI at solving various problems?
All right, well, complex problems, if you approach the idea of solving them by component pieces, that's a concept that's been around since the 1940s. Various mathematicians have theorized on this and how to solve problems that are bigger than the simple reductive logic problems. The approach there and why we are using a Gestalt AI here is it allows us to take different aspects of the problem and solve them to the best fit case that they're using, and we can put those together in different manners. We can solve ensemble problems where there's a collection of possible ways of getting an answer and different objective answers that are needed, but they need to be used in cooperation in order to meet a real world problem that has to be solved, meaning it's not just a single problem at one time, but it's a collection of problems either competitive or in competition or cooperation that have to be solved together. Allowing these AIs to be built once and to talk with each other and cooperate with each other without having to build another AI to do that is a unique feature of the particular design we have in our Gestalt AI. So what does that mean in proper deployment terms? If you build an application to solve a problem, what's the likelihood that somebody cares about that particular outcome and is willing to go and do it? That generalized problem can be solved in 3,400 lines of application code. That application can be deployed to a whole raft of people in different industries, all who need that solution. And that one solution can be put together in combinatoric and in piecemeal part with other solutions to solve really big problems. And it does it without having to do a complete redesign and retrain. This now gets to the place where we have reusable AI code. We design it once, we perfect the concept of the application, and we reuse that over and over again. It doesn't preclude the ability to make changes or adjustments to it. For example, we had a request to be able to add labeling to something. And what would you use labeling for? Well, in mathematical terms, it would be another way for us to group information together and let that information alignment either create a constructive case for something occurring or rejecting a case so it can't occur unless the information is present. And we don't have to do that with a new algorithm. We just stick labels on the data and move on. These kinds of solutions will open up massive capabilities in artificial intelligence development because we could put hundreds of different AIs together and solve very complicated problems and just reuse that code and then do the fit and finish work at the end. Faster to market, lower cost, lower operational expense.